Namaste one and all. This is Vijay Krishna, Assistant Professor in Mathematics from Sri Institute of Technology and Engineering, Tadepalligudem. Today, I am going to discuss about volume integral. So, you know what is the line integral, surface integral. So, after learning the line and surface integral, we want to learn volume integral. Here, f bar is f1 I bar plus f2 j bar plus f3 k bar be a vector point function. Here, where f1, f2, f3 are functions in terms of x, y and z. Okay, then volume integral of f bar is given by integral over v f bar dv equal to triple integral f bar dx dy dz. So if you want to evaluate the volume integral is nothing but evaluate the triple integral, one integral for x, another integral for y, another integral for z. Okay, so finally integral over v f bar dv equal to triple integral f bar dx dy dz. Right, now coming to the problem, here problem is if f bar equal to 2x square minus 3z into I bar minus 2xy j bar minus 4x k bar, then evaluate integral over v del dot f bar. What do you mean by del dot f bar? Del dot f bar is nothing but divergence. Divergence of f bar. Do you remember the formula for divergence? Yes, the divergence of f bar equal to dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Right? So now, where fv is the closed region bounded by x equal to 0, y equal to 0, z equal to 0 and 2x plus 2y plus z equal to 4. So here all variables are lower limits are given. So next we want to find upper limits only. Okay, so here z equal to 0. So when we calculate z upper limit, z equal to, substitute z equal to 0 and write z value here, then z equal to 4 minus 2x minus 2y. So z equal to 0 and z equal to 4 minus 2x minus 2y. Okay, so therefore we got the limits, z limits, we got the z limits we got the z limits 0 to 4 minus 2x minus 2y. Okay, so after getting the z limits, we want to find y limits. So here y equal to 0 and z equal to 0. Substitute z equal to 0 in this equation, then this equation becomes 2x plus 2y equal to 4. Okay, by this equation, write 2y equal to 4 minus 2x. Okay, so divide with 2, then we get y equal to 2 minus x. Right? So finally y equal to 2 minus 2x. Therefore, y limits 0 to 2 minus x. Okay, so we got z limits 0 to 4 minus 2x minus 2y and y limits are 0 to 2 minus x. Now we want to find x limits. So here x equal to 0, that is the lower limit. Now after getting the y and z limits, substitute both the values here zeros, then 2x equal to 4. Then we get x value 2. Okay, x value 2. So finally we got x limits 0 to 2. Okay, so finally we got x, y, z limits. X limits are 0 to 2, y limits are 0 to 2 minus x, z limits are 0 to 4 minus 2x minus 2y. Okay, now we want to calculate del dot f bar. Nothing but divergence of f bar. So divergence of f bar formula dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Okay, so what is f1, what is f2, what is f3? So when we observe the given f bar, 2x square minus 3z into I bar minus 2xy into j bar minus 4x k bar. Here this is 2x square minus 3z is f1, minus 2xy is f2, minus 4x is f3. Okay, now we have to calculate divergence by substituting f1, f2, f3. Then we have dou by dou x of f1. What is f1? 2x square minus 3z plus dou by dou y of f2. What is f2? Minus 2xy plus dou f3 by dou z. So dou by dou z of f3 minus 4x. Okay, so when we differentiate partially with respect to x, y, z, so if you differentiate with respect to x, remaining two variables y, z are constants. Okay, then in similar manner when we differentiate with respect to y partially, remaining two variables x and z are constants. When we differentiate with respect to z, remaining two variables x and y are constants. So in that manner, dou by dou x of 2x square we get 4x. Dou by dou x of minus 3z, here z is a constant, 3 also constant, so derivative of 3z is 0. Now here plus into minus, minus 2xy. In 2xy, when differentiating with respect to y, 2x are constants, remaining y derivative 1. Okay, now here minus 4x, dou by dou z of minus 4x, it is completely in terms of x, there is no z, so it is completely constant, so derivative of minus 4x is 0. Okay, so finally we got 4x minus 2x equal to 2x. This is del dot f bar. We want to evaluate integral over v del dot f bar dv. Okay, so now coming to the integral over v del dot f bar dv. So integral over v nothing but triple integral. So x equal to 0 to 2, y equal to 0 to 2 minus x, z equal to 0 to 4 minus 2x minus 2y. Okay, del dot f bar is nothing but 2x dx dy dz. So how to evaluate triple integral? First evaluate the inner integral, that is integral with respect to z. So when we integrate with respect to z, remaining variables are constants. So here 2x, it is completely constant. Take outside, remaining 1. Integral 1 dz, z. So equal to integral x equal to 0 to 2, integral y equal to 0 to 2 minus x, 2xz. Okay, limits z equal to 0 to 4 minus 2x minus 2y, balance dy dx. Okay, now substitute the limits. First apply upper limit in place of z, then we have integral x equal to 0 to 2, integral y equal to 0 to 2 minus x, 2x into z value 4 minus 2x minus 2y. When we apply the lower limit, it will completely 0. So balance dy dx. Okay, dy dx. Now integral x equal to 0 to 2, integral y equal to 0 to 2 minus x, 2x into 4 minus 2x minus 2y, balance dy dx. Okay, now here multiply with 2x, then integral x equal to 0 to 2, integral y equal to 0 to 2 minus x, 2x into 4, 8x, minus 2x into 2x, 4x square, 2x into minus 2y, minus 4xy, balance dy dx. Okay, now evaluate the inner integral with respect to y first. Then integral x equal to 0 to 2, here integral 8xy, minus integral 4x square y, minus 4x are constants, integral y dy y square by 2. Okay, so overall limits y equal to 0 to 2 minus x dx. Right, here 2 2's are cancelled. right? Now apply upper limit. What is upper limit? 2 minus x. Apply upper limit 2 minus x in place of y. Then integral x equal to 0 to 2 8x into 2 minus x minus 4x square into 2 minus x minus 2x into 2 minus x whole square. When we apply the lower limit, completely becomes 0. So, balance dx. Okay. Now, integral x equal to 0 to 2 multiply with 8x. 8x into 2, 16x minus 8x into x, 8x square. Here, minus 4x square into 2, minus 8x square. Minus 4x square into minus x, plus 4x cube. Here 2 minus x, when we expand the 2 minus x, first constant is 4. 4 into minus 2x, minus 8x. Next, plus x square. Plus x square into minus 2x is minus 2x cube. Okay? Minus 4x. Minus 4x into minus 2x, plus 8x square dx. Okay, this is a minus 8x square, this is plus 8x square. Cancel, balance, integral x equal to 0 to 2, 16x minus 8x. So balance 8x. Okay, minus 8x square. 4x cube minus 2x cube plus 2x cube dx. Now evaluate the integral with respect to x. Then integral 8x square by 2 minus 8 constant integral x square is x cube by 3 plus 2 constant integral x cube is x power of 4 by 4. Overall limits 0 to 2. Now apply upper limit, that is 2 in place of x. Here 2 4 the cancel. 2 square 4, 4 into 4 16. Okay, 2 cube 8, 8 into 8 64 by 3. Okay, here 2 2 the cancel, right? 2 power of 4 16, 16 by 2 8. Okay, when apply the lower limit, all the terms becomes 0. So 16 plus 8 24 minus 64 by 3. Take LCM. LCM is 3. Okay, right. Then numerator becomes 3 into 24. 3 4s are 12. 2 and 1. 3 2s are 6. 7. Minus 64. 72 minus 64. So 12 minus 4. 8. Okay. So 6 minus 6. Finally we got 8 by 3. Okay. So this is the answer. Integral over V del dot f bar dv. Right. So now coming to the next problem. Here, see the problem once. Here f bar is 2xz I bar minus xz bar plus y square k bar. Okay. So this is of the form f1 I bar. Okay. Plus f2 z bar plus f3 k bar. Here f1 is 2xz, f2 is minus x, f3 is y square. Then we want to evaluate integral over V f bar dv. Here not del dot f bar, integral over V f bar dv, where V is the volume of region bounded by the surfaces x equal to 0, x equal to 2, y equal to 0, y equal to 6, z equal to x square and z equal to 4. So clearly x, y, z limits are given. Okay, x limits are 0 to 2, y limits are 0 to 6, z limits are x square to 4. These limits are given in the problem clearly. Okay, so given one vector void function which is in the form of f1 I bar plus f2 j bar plus f3 k bar. Right, we want to evaluate integral over V f bar dv. So integral over V f bar dv, nothing but triple integral f bar dv. dv means dx, dy, dz. So how to evaluate triple integral f bar dx, dy, dz? Is nothing but triple integral f1 dx, dy, dz, I bar, okay, plus triple integral f2 dx, dy, dz, j bar, plus triple integral f3 dx, dy, dz, k bar. So this is the volume integral of f bar, okay, which is in the form of triple integral f1 dx, dy, dz, I bar, plus triple integral f2 dx, dy, dz, j bar, plus triple integral f3 dx, dy, dz, k bar. So if you want to evaluate the volume integral of f bar, which is nothing but to evaluate in three parts. One is triple integral f1 dx, dy, dz. Another one triple integral f2 dx, dy, dz. Triple integral f3 dx, dy, dz. So first evaluate the first part, that is triple integral f1 dx, dy, dz. So what are the x limits? X limits are 0 to 2. Okay, x limits are 0 to 2. What are the y limits? 0 to 6. Next, write the z limits x square to 4. Z limits are x square to 4. F1. What is F1? F1 is nothing but 2xz. Okay, dx, dy, dz. So if you want to evaluate the triple integral, first we have to evaluate inner integral. What is the inner integral? Your inner integral with respect to z. So integral with respect to z. So when we evaluate the integral with respect to z, except z, remaining variables are all constants. So 2x constant, integral z square by 2. So both 2 and 2 are cancelled. Then we have integral x equal to 0 to 2, integral y equal to 0 to 6. Remaining 2x into z square by 2. Here 2 are constant, cancel. Remaining limits x square to 4. Balance dx, dy. Okay. Now apply upper limit. What is the upper limit? 4 in place of z. So 4 square 16. 16x. So integral x equal to 0 to 2. Integral y equal to 0 to 6, 16x minus, apply lower limit x square in place of z, then we have x power 4 into x power of 5, okay, dx, dy. Clear? Now evaluate the next inner integral. That is, next inner integral is integral with respect to y. So when we evaluate the integral with respect to y, remaining variable x is constant. So here 16x minus x power of 5, it is completely constant. Take outside. Remaining 1. Integral 1 dy, y. Okay. So integral x equal to 0 to 2. 16x minus x power of 5 into y, balance limits 0 to 2 minus 0 to 6, balance dx. Okay. Now we apply upper limit, that is 6 in place of y. Then integral x equal to 0 to 2, 16x minus x power of 5 into upper limit is 6. When apply the lower limit, it will completely 0. So balance dx. Okay. Now multiply with 6. Then integral x equal to 0 to 2. 6 into 16, 96 x minus 6x power of 5 dx. Now evaluate the integral with respect to x. Then 96x square by 2. 96x square by 2. Minus 6 into integral x power of 5, x power 6 by x power 6 by 6, limits 0 to 2. Okay. So 96 by 2, that nothing but 48. Okay. 48 x square. Here 6 cancel. So when we apply the upper limit, x square ante 2 square 448 into 4 minus 2 power 6. 2 power 6 nothing but 2 square 4 into 4 2 square into 2 square into nothing but 2 square into 2 square 16. Okay, 16 2 square 2 square 2 square. So 16 into 4 64. Okay, so 4 8 is 32 3 4 4 is 16 plus 3 9 192 minus 64. So 12 minus 4 8. Okay, so 8 minus 6 2 balance 1. So 128. Okay, the first part of the integral is 128. Okay, next we want to evaluate second part, triple integral f2 dx dy dz. Okay, so now here f2 is minus x. Integral, triple integral f2 dx dy dz, so equal to integral x equal to 0 to 2, integral y equal to 0 to 6, integral z equal to x square to 4. Okay, f2 value minus 2x dx dy dz. Now evaluate the inner integral, that is the integral with respect to z. So here minus 2x, there is no z, so it is completely constant. Then integral x equal to 0 to 2, integral y equal to 0 to 6 minus 2x into z, limits x square to 4, balance dx dy. Okay, now we apply upper limit. Then we have integral x equal to 0 to 2, integral y equal to 0 to 6 minus 2x into 4 minus 8x minus 2x into x square minus 2x cube, so plus 4x cube plus 2x cube. Okay, dx dy. Right, so now evaluate the inner integral with respect to y. Okay, so when we evaluate the integral with respect to y, except y remaining variable is constant. So here there is no y, minus 8x plus 2x cube, there is no y, so it is completely constant. Take outside, remaining integral x equal to 0 to 2. Okay, 2x cube minus 8x into y. So y limits are 0 to 6. First apply upper limit. What is the upper limit? 6. Okay, so when we apply the upper limit, we get 6 into integral x equal to 0 to 2, 6 into 2x cube minus 8x. Okay, so when we apply the lower limit, it will become 0. Okay, now integral with respect to x. Here 6 is a constant, take outside 6, remaining 6 into remaining integral 2x cube, 2x power of 4 by 4. Next, minus integral 8x, 8 into x square by 2, limits 0 to 2. Okay, so here 2 4 the cancel, here 2 2 the cancel, then 6 x power of 4, 6 into x power of 4 by 2 minus 4x square. When apply the upper limit to 2 power of 4, 16, 16 by 2, 8 minus 4 into 2 square, 4 into 4, 16. Okay, 8 minus 16, minus 8. Minus 8 into 6, minus 48. Okay, so when apply the lower limit, it will completely 0. So this is the value of the second part. Okay, now coming to the third part. Here, third part is triple integral f3 dx dy dz. What is f3? f3 is nothing but here y square. f3 is y square, right? So now calculate triple integral f3 dx dy dz. Okay, so triple integral, one integral for x, limits are 0 to 2. Second integral is for y, limits 0 to 6. Third integral is for z, limits x square to 4. Okay, f3 y square dx, dy, dz. Now evaluate the integrals one by one in the last, from the last. Okay, so here the inner integral is with respect to z. So except z, remaining variable is constant. So y square constant. Then integral x equal to 0 to 2, integral y equal to 0 to 6. Now y square z, limits x square to 4, balance dx, dy. Okay. Now apply upper limit 4, then we have integral x equal to 0 to 2, integral y equal to 0 to 6, we have 4y square minus, apply lower limit x square, we get x square into y square. So balance dx, dy. Right? So now evaluate the another inner integral, that is integral with respect to y. Okay, so here with respect to y means x constant, keep in your mind. So integral 4y square, 4y cube by 3. So integral 0 to 2, 4y cube by 3 minus integral x square constant, integral y square is y cube by 3. Okay, limits 0 to 6. So balance dx. Okay, so now integral 0 to 2, 4 minus x square into, here y cube by 3 common, take y cube by 3 common, then y cube by 3 limits 0 to 6, balance dx. Okay, apply upper limit is 6 cube by 3, 6 cube, 36 into 6 by 3, 3 to the cancel, 36 into 2, so 2 6 are 12, 2 6 are 12, 1, 2 3 are 6 plus 1, 7, so 72. 72 is completely constant, take outside. Okay, so remaining integral 0 to 2, 4 minus x square dx. Okay, now evaluate the integral with respect to x, then 72 into 4x minus x square integral x cube by 3, limits 0 to 2, then 72 into, apply upper limit 4 into 2, 8, minus 8 by 3, then when apply the lower limit it will completely 0, then 72 into, take 8 common, we have 1 minus 1 by 3, 1 minus 1 by 3 nothing but 2 by 3, so 72 into 8 into 2 by 3. Okay, then 3 2s are 6, 1, so 3 24s are 72, right? So 24 into 2, 48, 48 into 8, 8 8 is 64, 6, 8 4 is 32 plus 6, 38. Okay, so this is the third part value. Okay, so now substitute all the parts in the above, then we get required answer, triple integral. That is, first part is I think 128, so 128 I bar minus 48, that is the second part value, minus 48 into j bar plus third part value 384 into k bar. So this is the volume integral of f bar which is given in the problem. Okay, thank you very much.